Hello all, we are Vijayalakshmi and my teammate Shankari, currently pursuing our bachelor's degree in SSN College of Engineering. As a part of our internship at Emertex, we have undertaken a project titled Washing Machine Stimulation using Picsimlab. In this project, we have used embedded C programming with PIC16F877A microcontroller to simulate the basic operation of washing machine. So let us, so these are the table of contents, and this is, let us see what is embedded system. Embedded systems are specialized computer system designed to perform specific control function within larger system. They are everywhere around us. And the key challenges is they operate under real time. So they must respond to inputs and produce accurate outputs. Some common examples include washing machines, car ECUs, medical devices, and in automotive devices. So embedded C is highly efficient and works close to the hardware. It allows direct hardware control such as accessing the registers and ports. Highly portable across different microcontrollers. So let us see about embedded C. So first let's start with the keywords. Keywords are also known as reserved words. They mean specially to compiler. Special functions are assigned to it and it cannot be used as variable names. For example, if, else, while, int, char, float, volatile, static are examples of keywords. These are the basic building blocks of any C programs. Data types. They define what kind of data a variable can store. So specific size and types of values a variables can hold. Common data types include char, which means the character. It requires 1 byte of for storing. Int requires 2 or 4 bytes. Float requires 4 bytes, and double requires 8 bytes. And also signed and unsigned categories is also available. Signed includes the positive and negative values, and unsigned holds only the negative values. So now let us see about the conditional statement. These help the program make decision. If, else if, and else are used to choose different action as given in the code. And there is a ladder case which includes the if, else if, and else conditions, and switch case. So switch case is used with multiple possible values for a variable and different actions for each. You can also use signed and unsigned types to control whether a value can be negative or only positive. Next comes the operators. So operators perform action like mathematical and or comparisons. So the types include arithmetic operators, which includes the addition process, subtraction, multiplication, division, and modulo operator. Next comes the relational operators. This is basically used for comparison. Double equal to represents the whether the one value equals the other, and other the next operator not equal to represents the comparison between the two operators, and less than or equal to. Logical operators includes and or not. Bitwise operators includes and or XOR, not, left shift, right shift. These are basically the logical operators. And assignment operators include single equal to sign, plus or minus equal to, and increment decrement includes the double positive sign and double negative sign. Let us see about the array, which stores multiple value of the same data type under a single variable name. So it can be declared as a data type and space, array name, and the specific size should be specified inside the braces. For example, int space sensor reading, and the size should be mentioned in the braces. You can access the values using index numbers starting from 0. It is useful for storing sensor data, button states, etc. Next comes the function. So functions break your code into reusable blocks. They make your program cleaner and easier to manage. Each function performs a specific task. Pointers. Pointers are it stores the variable that stores the addresses. Powerful feature for direct memory manipulation. It is declared as data type star pointer name. and address of the operator is specified as and it gets the memory of the address variable. Dereference operator is represented as star symbol, access the value at memory address pointed to by a pointer. And the applications of pointers include efficient array manipulation, dynamic memory allocation, interfacing with hardware registers. The next comes the macros. It is defined using the hash defined preprocessor directive performed before compilation, and the syntax is given as below. Hash define macro underscore name space replacement text, and the constant is defined as hash define led underscore pin underscore do and 0x01. So the advantages of macros are code readability and no function call overhead. Disadvantages include no type checking and it can lead to unexpected behavior if not careful. So the reason for choosing PIC16F77A because it is an 8-bit RISC processor from Microchip and it has 8 KB of flash memory, 368 byte of RAM for variable and data, and 256 bytes for EEPROM for permanent data storage, and it can run up to 20 megahertz. It has 33 input-output pins for connecting the sensors, displays, and controls. Also, it includes peripherals such as ADC, timers, PWM, pulse width modulator, SPI, and I2C USR ports. So this helps in so integrated. It has the integrated peripherals for diverse project ideas, and it is very helpful in the controlling washing machine. So this is the pin diagram of PIC16F77A. It has up to 5 ports. Port A contains 6 input-output pins and port B contains 8 input-output pins. Port C contains 8 input-output pins. Port D contains 8 input-output pins. Port E contains up to 3 input-output pins. So VSS and VDD is for ground and power supply respectively. So oscillator pins are required for clock storage and it contains up to 2 oscillators. So the next come timers. Timers are essential for time-based operations, which is essential in real-time functions. It is used for delay generation, creating precise time delays, event counting, counting external events, and time measurement to measure the duration of the event, and PWM generation, pulse width modulation for motor control and dimming LEDs. So there are up to 3 timers. Timer 0 is 8 bits and it is a basic timer or counter. It can be used as both timer and counter. Timer 1 contains 16 bits. It can be synchronized with the external clock, ideal for precise timing. Timer 2 is of 8 bits. It is often used for pulse width modulation generation and baud.
Hello everyone, I am Shankari. I will cover the software requirements, hardware peripherals, and the demonstration of washing machine. So let's see what are the software that we need to provide or to do a project software washing machine. Okay. First one is integrated development environment, which provides a comprehensive environment for coding, compiling, and debugging. And the next one is compiler, which translates the high-level C code into machine-level readable assembly or hexacode. And the final one we need is simulator or debugger. It allows us to testing and debugging code without the actual hardware. Okay. Let's see specific ones for each. First one is MTLab X IDE. It is developed by the Microchips Development Environment. Its purpose is for PIC microcontroller. The key feature of this IDE are it will highlight the syntax and auto code completion, and it also organize source files, headers, etc. And it is used by step-by-step execution, breakpoints, variable inspection, etc. And it supports for various tools such as compilers, programmers, and debuggers. And it is also available for cross platforms such as Windows, Mac OS, and Linux. And the next one is Picsimlab. It is a real-time microcontroller simulator. It will simulate various microcontrollers, including PICs. Let's see the key features of Picsimlab. It provides us visual simulation. We can see the real-time behavior of components such as LEDs, LCDs, motors, and etc. And it also provides us the breadboard view so that we can drag and drop components to build the circuits. And next one is interfacing. It connects virtual peripherals such as sensors, actuators, etc. And we can also upload code using this Picsimlab. It loads compiled hex files directly. And the basic debugging capabilities available within the simulation. It is excellent for learning and prototyping without any hardware. Next one is compiler. We use MPLAB XC8 compiler, which is converts C code written for 8-bit PIC microcontroller into machine code. The key feature of these compilers are it provides us the optimizing compiler, which generates efficient and compact code, and peripheral libraries. It provides headers and functions to easily control PIC peripherals, and it supports C conforms to C standards with embedded extensions, and it is integrated with MPLAB XIDE for seamless compilation process. And the best thing is it is free and pro versions are available. We are going to use free version for our washing machine demonstration. Okay. So far we have seen the software requirements. Let's see the hardware peripherals that we need. First one is digital keypads. In a washing machine embedded system, user interaction is crucial. So, the user needs to select washing mode, start or pause, the cycle power, which is on or off, set timers or speed levels. Since this setup uses digital switches such as keypad buttons, digital keypad handles the logic for reading key press events, including short presses and long presses. And the next one is CLCD. It is a dot matrix liquid crystal display. It can be used to display the characters, alphabets, numbers, and even emojis also. It is available in different modules like 6 cross 2, 16 cross 4, 20 cross A, etc. And it has 16 columns and 2 rows. It operates on 4-bit mode or 8-bit mode with microcontroller or microprocessor pins. And it has VSS, as we all know, it is a ground pin, and VDD, which supplies 5 volt, contrast control, register select, read or write. For read it is 0, for write it is 1. Enable pin D0 to D7, which are digital data pins. Okay. Let's see the entire washing machine project details. We are using microcontroller based micro washing machine simulation using Picsimlab. The main purpose of this project focuses on simulating a washing machine using Picsimlab, aiming to replicate real world washing machine functionality in a virtual environment. The project begins with a comprehensive understanding of washing machine components, cycles, and operations. Parameters defining laundry status such as fabric type, load size, water level are identified. Okay. The scope of this simulation project provides valuable insights into washing machine operation, control system design, and the simulation techniques. Let's see the functional requirement. The boxes whichever present in the left side are inputs and the boxes whichever present in the right side are output. So we will switch on the fifth switch to power on the washing machine, and switch 6 for pause or stop, switch 4 for navigation, and switch 1 for door status. This all will go into the microcontroller. As a result, we'll get a display. From that, we will know the washing status, that is through CLCD, and a buzzer and a motor. Okay, this is the main thing of the washing machine simulation. Let's see the descriptions of washing machine. The first one is power on. Once washing machine program and water level is selected, provide user option to start the machine. So first we need to start the washing machine, so that we need to press the button switch 5 so that it will start the machine, display the function selected and the time taken. Then switch to function screen. Okay. Whenever we start, it will show us the machine started and how long it will take, like time taken and all it will show. Then it will switch to the function screen, which is the second screen. Okay. In this washing program screen, we will have lots of options and a menu such as daily, heavy, delicates, white, stain wash, like that we'll have. In that, to need to select, we will click a switch 4 highlighted with a star, and to need to go to next screen, we'll keep on pressing the switch 5. Okay. In switch 5, we can select the water levels. It will show auto, low, medium, high, and low, like that. To need to select, we'll keep on pressing switch 4 to select. And to go to next screen, we'll keep on pressing switch 4. Okay. And start screen. Once washing machine program and the water level is selected, it will provide user option to start the machine. Switch 5 is pressed, it will start the machine, display the function selected and the time taken. Then the function to next screen. Okay. To start the washing machine, we'll click switch 5, and to stop, we'll click switch 6. In between, if the door is opened or closed, we can check by clicking switch 1, so that if the door is open, it will provide us a message called please close the door, it is open. So that we can be aware of that washing machine's door is open. Okay. Then at last we can pause using switch 5. Then output will display like program completed, remove your class. Okay. This is the basic and the simple description of our washing machine demo description. Let's see in the Picsimlab through demonstration. Mm, okay. As you already saw in the Pixim simulator, these are the just screenshots for your easy understanding. First, the machine power ons, then it will show us the menu, daily, heavy, delicates. Then it will allows us to select water levels. Then it allows us to press start or stop. When we click start, the timer will started, and we need to stop means we can click 6 to pause. Otherwise, to see the door is opened or closed, just click switch 1. If it is open, it will warn us, please close the door, like that. After that, the time completes, it will provide us the message completed, remove your clothes. Okay. This is what our washing machine does, which is a replicate of real world washing machine. Uh, this is the Pixim Lab simulator. That's the snapshot. Okay, let's see the demonstration of washing machine on a Pixim lab. First one is, as we see in the description, we need to power on the washing machine. So that we will need to click the button RB4. It's working. Let's see. Yeah, our washing machine is powered on. So as we can see in the CLCD display. Now we need to click RB3 to select the options. It shows me daily, heavy, delicates. To go to next options, we need to click RB3 for long time. It is a long press. To go to other options, we can click and just press, not a long press. So we can get different types of options. Now I selected delicates and going to long press to get the next program, that is water level. It shows I selected whites now. I'm going to keep on pressing RB3 to get water levels. See, I clicked whites. As I said, we got the water levels which shows auto, low, medium. To get other options, just press RB3. We'll get low, medium, high. As of now, I selected the low water level. Then I need to keep on pressing RB3 to start the washing machine. Like to get the screen of starting the washing machine. Yeah. Now if I press switch 5, it will start the washing machine. If I press switch 6, it will stop. Okay. I am going to click switch 5, that is RB4. It shows me whites, which I selected earlier, and the time is 1 minute 16 seconds. Okay, it gets started. To stop in between, we can select switch 6, that is RB5. If I select this, it will pause. You can see the machine is stopped. If you want to start again, just click switch 4, that is RB4. Again, it resumes. Okay. And another one we added here is when the door is open or closed. If it is open, it will throw us a message so that we need to click RB not. So it is said me, you can see door is open, please close the door. Okay, this is the warning message we can get. And the washing machine again started running. Okay, it will take 60 more seconds to complete the washing the clothes. So let's wait for that. This is the Pixim simulator. In that we set the clock as 8 megahertz and the speed is 1x and the LCD display is HD 44780 16 cross 4. We choose the cooler and this is the CLCD display. These are the switches. Previously we mentioned the switch 5, switch 6 and all, but here it starts from 0. So that's why when switch 5 is mentioned, we'll click the RB4 button. Okay, um, that's it. And it takes 36 more minutes to complete. Until then, we can wait for. This is the CLCD. As we saw already, it has different types of frames, that is 16 cross 2, 16 cross 4 and all. Among them, we have chosen 16 cross 4 so that we can able to see the screen properly and it is quite larger than compared to 16 cross 2. Mm, it will take 19 more seconds. Once it is completed, it will display as the completed message so that we can collect our clothes. Thus, we can implement a real-time washing machine problem implementation in the Picsimlab with the help of microcontroller, that is MP Lab XIDE and a compiler and Picsimlab simulator. 9 seconds. That's it. We choose the function spin. Previously it is a wash. Now it turned into spin. That means the process is completed. Now it is spinning and it's going to come in now. Yeah, that's it. Our program completed. We can remove our clothes and the washing machine also stop. Okay, it starts again. So we completed successfully implemented our project in the Picsimlab simulator. Okay, learning outcomes. We learned deeper understanding of embedded C programming, and we got hands-on experience with embedded system design and implementation, and we got familiarity with MPLAB, XIDE, XCA compiler, and Picsimlab simulator. We successfully simulated a real-world washing machine using a specific microcontroller called PIC16F877A and its peripherals, and we gained experience in debugging and troubleshooting embedded system. Okay. Thank you, Emertex, for giving us this wonderful internship opportunity. We learned embedded C in and microcontroller. Thank you.